This is Nitin Dahat with the Times. I'm here at the IEDM conference in San Francisco and talking to Jean-René Lequepeys, who's the CTO and Deputy Director for CA-Leti. Jean-René, hello.
Hello, Nitin.
How are you?
Fine, thank you, and you?
So, fine, thank you. Well, we have been discussing the update to the FAMES line. It's a big European project. Which I think 830 million euros funding. So tell me about the FAMES.
So the FAMES pilot line is a project which has been constructed inside the EU Chip Act in Europe. And so we launched this initiative in 1st December 2023 with an outstanding consortium. Inside our consortium, we have IMEC, Fraunhofer, VTT in Finland, in Tyndall in Ireland, Silicon Austria Lab in Austria, and also three well-known universities, University of Granada, University of César-Mat-Wut in Poland, and University of Catholique de Louvain.
Okay.
And we welcome also our engineer school in Grenoble.
Yes.
And the CNANO inside France to be part of this initiative. It's a big project of 830 million euros, and 728 million euros are coming to CA-Leti in order to have, I would say, a big investment in terms of CapEx tool. So we could invest 333 million euros, and we have an OpEx cost of 395 million euros in order to allow, I would say, a workforce of 300 full-time engineers working per year on this project.
Very good. Now, what is the objective of FAMES? What was the mission? Because I think there's some interesting things going on, and you're basically coming down in terms of FD-SOI technology and looking at innovating in that area. Yeah,
it's an initiative which is combining 5 technologies. So we want to develop 2 new generation nodes of fully depleted SOI, 10 nanometers node and 7 nanometers node.
Right. And just to get perspective, right? Currently, you're at 22 and 28, 28 and 22 with Global Foundries.
28 and 22 are industrial technology which has been produced and which are currently produced by STMicroelectronics, Samsung, and the 22 is produced by Global Foundries.
Correct. Okay.
And based on the fact that key leaders like Qualcomm, Google, Samsung, NXP, Sony, Nordic select fully depleted SOI, it's become a necessity to prepare the future, to prepare 2 new generation nodes. Second objective is to add in the FAMES pilot line non-volatile memories inside the backend of line.
Okay.
And we are going to work on oxide RAM, on magnetic RAM, on Firo RAM, and on FinFET.
Okay.
In order to be able to select, I would say, the right memory for a mission profile.
Okay.
We will add also RF components, based on the fact that fully depleted SOI has very good properties for analog and radio frequency. We'll develop passive component, switches, and filters, which could be standalone or embedded in the backend of line.
Okay.
And in order to propose also to IC designers new features, we decide to put inside the project 2 3D options. Heterogeneous integration, thanks to chiplet and interposer, active or passive interposer, and 3D monolithic.
Okay.
And we also add, finally, some tiny inductance, and with those tiny inductance, we can develop efficient DC-DC converters for allowing power management integrated circuit and delivering all the voltage which are needed for complex SoC.
Okay. And now, one of the things I think we were talking about earlier before we came on camera is about the potential for breakthroughs in new architectures. Can we just talk a little bit about what you might potentially see?
All those 5 technology could be combined together in order to open new research avenues for IC designers and disruptive architectures. For example, we can get rid of Van architectures by avoiding moving the data. Yeah. And
because of the computing memory potential for this.
Computing memory and to make some in-memory computing, we can go towards 3D. We can go towards 3D integration inside the front end of line. And we can add also non-volatile memories for IoT devices, just to cut the VD and to save the information inside, I would say, a memory and to start again very rapidly.
Okay.
So, and we could add also some RF component.
And that potentially will allow the companies that you license the technology to to enable some
Yeah.
innovative ways of addressing some of the challenges in
Of course,
system
those
on
technology has
design.
to be used by industrial company after that and licensed in a fair, reasonable, and non-discriminatory way.
Yeah, that's the requirement of the EU
It's
for
a
this
strong
funding. Yes.
requirement,
Yeah.
And we have been supported by 43 big key players in the world.
Right.
Like companies like Nokia, Siemens, Qualcomm.
Yes, you
Meta,
have an impressive slide.
IBM. And there is an impressive sign. And all the key names in Europe and in US are
Yeah.
already in this project. And all those partners want to evaluate the technology, to test the technology, and after that they want to integrate in a further step
Right.
the technology into their product in order to consolidate their market share and to open new revenues coming from new products thanks to the FAMES pilot line.
Okay. So what about timelines? So you said you have a number of tools already. When can...
Yeah, we start the project at European level on the 1st December 2023. We acquire 30 tools in the first year. 25 of them are ready to use in our clean room.
Right.
And it is based on an existing infrastructure because we have already 700 equipment in our 11,000 meters square of clean room.
Okay.
And we will acquire, I would say, 40 new equipment in order to complement the pilot line. And the project will last until December 2028.
And you have an open call coming out early next year.
Yeah.
So then what's the timeline on that?
Yeah, we have open call every year. And there will be the first open call will be launched in March 2025, so very soon now. And there will be a workshop in Brussels, 18 of March, in order to present the content of the open call. And we will have also some school, summer school, in order to prepare people from the FAMES pilot line technology and to explain to them.
Okay, and this open call is then for the companies to potentially get their hands on the technology, early hands on technology?
Yes, to test in an advanced period. And also we have inside the FAMES pilot line, we have an external industry advisory board.
Okay.
And we will welcome on board some industrial companies to provide advices.
Okay.
They will test the technology and they provide also advices to be sure that the technology we are going to develop with so big budget will be useful for industry and useful for the semiconductor industry. And all those results will be also open not only to all EU stakeholders in Europe, but also in all EU like-minded countries, partners.
Right.
So it's an important feature because there will be a baseline of R&D which will be paid 100% by public national authorities and by EU Chip Act.
Yes.
And industrial companies will pay only for the additional cost in order to deliver the services, R&D services, which will be needed for him.
All right. Last question. So you didn't present IEDM here, but I guess you'll be presenting some of the aspects of the technology next year?
Of course, in IEDM we have, depending on the year, we have between, I would say, 10 to 15 papers accepted. So, of course, based on the FAMES result, there will be publication at IEDM very soon, and I hope next year.
Okay. Well, Jean-René, thank you very much.
Thank you very much, Nitin.
Thank you.